Miss Tuesday's lesson, the recordings are up on the board. Not up on the board, what am I saying? The recordings are up on the website, and you can access them there, all of our recordings, okay, on other topics as well. There's a whole lot of recordings on the website and on YouTube, so there's lots of lessons that you can watch. In the meantime, we're going to have a little warm-up exercise. We're going to see who can remember what we did from Thursday. And there's a little activity here that I want everyone to do. I'm going to give you 3 minutes. I'll read quickly, and then you're on your own with the answers. I have 10 different shirts to choose from. 3 blue shirts, 2 red ones. Let's just go. 1 yellow shirt, 3 green shirts, 1 orange, and 1 purple. Skoko, just double check that there are actually 10 shirts now and that I didn't mess the whole thing up. 5, 6 plus 3 is 9, 10. Let's actually,
11.
Is there 11 shirts? Okay, so let's take out the yellow shirts. No more yellow. Okay, sorry guys, we're just quickly fixing the question. Okay, so 2 blue, 2 red, 3 green, 1 orange, 1 purple. So in the table, you have to match the words with the description. So there's number 1, 2, 3, 4, 5, 6, and you have to match it with A, B, C, D, E, F. Okay, 2 minutes. Let's go. Let's see. What are our answers? Hold your answers, please, until I call for them. Just jot them down on a piece of paper. Remember that Ms. Coco is our teaching assistant, so if you do have any questions or technical issues, she is right here to help and support. Okay, 1 more minute. Okay, let's see. Put your answer in the chat. What did you say? Shirts. What does that match with? From A to B to F, what does that match with? What would best describe all those shirts? What does it tell us? Anyone? Everyone's guessing B, but B is not quite the right answer. So Sipo, you have an answer. Do you want to give that?
Oh, good afternoon, ma'am.
Hi there.
Ma'am, I didn't have a question. I want to ask, did I miss anything important? My phone was giving me some connection problems.
No, we just started, so it's all fine. Yeah, we just started.
No problem.
Okay, so I do agree with those people who said C. All those shirts, that's our sample space. Okay. Why is that our sample space? Because that is what we can choose from. We can choose from those shirts. Okay, what is Picking a blue shirt. Now be careful because there's picking a blue shirt and then there's P blue shirt, which is 3. Picking a blue shirt, what does that match with? Put it into the chat. It's not F. It's D. I agree. It's definitely D, because picking a blue shirt is an event. Okay, an event. When we speak probability, this language of probability, picking a blue shirt is an event. Now, what is the probability of picking a blue shirt? Let's see that one. Put your answer in the chat. Yes, the probability of picking a blue shirt is A. And what about the probability of picking a pink shirt? E. Everyone got that one right. Good. Now, what about picking a shirt? It can only be B or F. That's F. Yes, that's an activity. And then the total outcomes, that is B. Okay, so the total outcomes is the total options, the total things that can happen. Okay, right, here's another question. Let's carry on practicing our probability and these ideas of elements, sample space, probability, etc. Okay, so a fair dice is rolled. Why is it fair? Because it's not leaning over to one side more or to the other side. It's completely random which number on the dice we are going to have. Okay, so the first question is, list the elements in the sample space. Okay, so I want you to pop that in the chat. What are the elements of the sample space? Remember, sample space is all the things we can choose from. So in the previous questions was all the shirts. Good stuff. Jurison got it. Lots of you got it. Well done. 1, 2, 3, 4, 5, and 6. That's our sample space. Okay. Now let's keep the answers coming nice and fast, guys. What is the probability that you will get a 6? Pop it in the chat, just as a fraction. You can just do it as a fraction. Nsako's first, and he says, or they say, it's 1/6. There we go, 1/6. And what is the probability of getting an odd number? Let's keep some answers coming. The probability of getting an odd number. Odd numbers will be 1, 3, and 5. So that is 3 out of 6. And we have to simplify. Everyone is giving me 3 out of 6, but forgetting to simplify. 1/2. Okay. And what is the probability that you will get a 7? 0. Okay. Now, what is the probability for number 4 that you will get more than 2? Good stuff. Bosiswa, Jerison, Lifa, nice answers, but we've got to simplify. 4/6 simplifies to what? 2/3. And you don't have to do this in your head. You can use your calculator for that. In grade 10, we can use our calculators. And then what is the probability that you will get an answer less than 10? Less than 10, you can only get an answer less than 10. So that is a probability of 1. Yeah, 6 out of 6. Or a probability of 1. Nice. Okay. Next up. Here's the next one. Everyone who hasn't answered yet, come. This is your chance. The spinner, here's our spinner. It's one of those little card things, and it's got that arrow dial on it, and it can go around, and then it lands on a certain color where the arrow is pointing. Okay, so not where this blunt end is pointing, but where the arrow is pointing. So list the elements of the sample space. So what's our sample space over here? It's different now. Guys, I don't see 1, 2, 3, 4 on this spinner, that's for sure. There we go. Yes, Bosiswa and Ntsako. Well done, Kobi. It is the different colors. That's our sample space. The things that can possibly happen. That's our sample space. Red, blue, and green. Okay, so what is the probability of the arrow of the spinner landing on green? 1 out of 4, easy peasy, well done. Kia, well done, everybody. And lastly, what is the probability of landing on yellow? Absolutely 0. We are not going to get yellow on the spinner. Well done. Okay, let's go on to our last one for now. We are going to keep practicing these lots today, but here's the last one before we do something slightly different. Okay, so we have here each letter of the word mathematics is written on a separate piece of paper of the same shape and size and put in a box. This is all very important because everything must be fair and exactly the same to make sure that nothing is biased or favored. Okay, so Nomsa closes her eyes and takes one piece of paper out of the bag at random. Now list the elements of the sample space again. So try now. This is third try. We can get it right. No, guys, let's list the elements of the sample space. Not how many elements are there in the sample space, but what are the elements? List them. Nice, and Ntsaku, I like that. Interesting. All the comma spaces. It's the letters of the word. Those are the elements of the sample space. So mathematics. Yes, Lihlumile. You can unmute Lihlumile and ask your question.
Mute. Ma'am, may you please get back to the first part? I didn't get that first part, ma'am.
Which first part?
Like the first part of the screen, ma'am.
Yeah, I can't go back now. We just need to finish this question. I can go back at the end, okay?
Yes, ma'am.
So,
thank you, ma'am.
Okay, so what is the probability that she takes a piece of paper with an M on it? Oh, some people are already answering. Nice, nice. How many M's have we got all together? Count carefully, Watobians. I count 2, not 3, so just be careful. It's 2 out of 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 letters in mathematics, and 2 of them are M's. Okay, and then what about the vowel? Remember vowel? A, I, E, O, those ones? Math, so the A, the E, the A, the I, so that is 4 out of 11. Okay, so just be clear, sample space, everything that we can choose from, okay? So the letters in mathematics, yes, there are 11 letters, but those are not the actual elements of the sample space. It's the actual things that make up. It's like all the shirts that you choose from, the letters that you choose from, the numbers that you can choose from. All those individual different ones make up the elements. Okay, so we're going to do something slightly different now. And I, this morning, was eating a piece of toast. And it had some jam on it. And I dropped it. And it landed up on the jam side, and I thought to myself, will that happen every time? So if I drop it, will it always land on the jam side? Ms. Kaka, what do you think?
I think yeah, I agree with someone named I am the guy who but nah, I don't think it'll always land on the jam side. I think, you know, depending on how it falls, it might land on either side. I don't know.
Okay, so think about if you've ever dropped your toast. People are putting like 1 out of 2 into the Kamba's getting scientific. He's saying it depends on science.
Yeah, he is right. There is a bit of a Kabi would cry, but there is a bit of a science to it. It has something to do with but yeah, sometimes it's not exactly a 50-50. But that's beside the point.
Okay, so you're saying that, okay, so for simplicity's sake, we can say that there's, and I think the Watobians agree, that there's a 50-50 chance of it either landing on the unbuttered or the unjammed side, or landing on the jam side. Okay, so let's stick to 50-50. So Kamva is saying the heaviest side will land on the floor. Okay. Did Mam's dog eat the toast? Okay, so then I decided to conduct an experiment because we need an answer. This is an important question. What side will land face down? The jam side or the unjam side? So I did this little experiment and I dropped it 25 times and it lands with the jam side up 16 times. Yeah, Mongezi is saying it depends on the distance to the ground. Okay, so, but this was my experiment, guys. I dropped it 25 times. And what happened was actually that out of the 25 times, it landed jam side up 16 times. Yeah, so 16 out of the 25 times, it landed with the jam side up. So that's not quite the 50-50 that we said, right? We would think, okay, there's 50-50 chance that it's going to land on the jam side or on the unjam side. Depends how you drop it, okay? But basically what it comes down to is that the probability, and just follow along on the screen, please, everybody, just underneath the yellow. Portia says also it will drop on the jam side, yeah. So the probability of your toast landing jam side up is, in this instance, with my experiment, trialing it 25 times, 16 out of those 25 times, it landed with the jam side up. Now, that is 16 out of 25. And if I write that as a decimal, it's 0.64. And then we can also write it as a percentage. Ivy's saying I ate the toast. Ivy, after dropping it 25 times, I don't know if I'm still going to eat it. I must be honest. Okay. So let's focus. Thanks, Ms. Coco, for that. So those are my that's basically with my experiment how it happened. I dropped it 25 times, 16 times, jam side up. So it's a probability during my experiment of getting 16 out of 25. Okay. And this is called the relative frequency. Okay, so there's a new word we need to know, is the relative frequency. It means that I did this experiment with my toast and this is basically the outcome. So I tried it 25 times and 16 times it landed jam side up. Okay, give me a thumbs up in the chat if you understand that. Thumbs down if not, but thumbs up if you understand this whole idea of my experiment with the toast. If you are not sure, please pop a question in the chat. And also to Ms. Coco. $25 was the number of times I dropped my toast. That's where the 25 came from. And then I counted it.
Ma'am, someone's asking, please repeat the definition of relative frequency.
Yeah. Okay. So the relative frequency, like I said, is when you conduct an experiment like I did, and you do something a certain number of times, and then you get outcomes a certain number of times. So in my example, with my silly little experiment with the toast, I dropped my toast 25 times, and that is basically the number of outcomes that each time, that was my sample space. And then my toast landing with the jam side up, that's 16. Okay, so relative frequency is something that happens when we do experiments. So it's not so much real world, and you're going to do one now, then you're going to see. Okay. You're going to do your own experiment now. You're not going to drop toast, but you are going to do your own experiment, and then you'll also understand a bit better. So if I now carry on, and this is how we use relative frequency. I did this experiment with 25 times. Now, obviously, I can't keep going. It is not realistic for me to keep dropping my toast. You all said already you're dropping your toast too many times, ma'am. So what if I dropped it 500 times? So if I dropped it 500 times, then I can use my relative frequency to make a prediction. And I can say this 16 out of 25, I'm going to times it by the 500, and that's going to give me 320. Okay, so we use relative frequency to make predictions. So my prediction is now, if I dropped my toast 500 times, it will land with the jam side up 320 times. Now, what if it's 1,000 times? I can make another prediction and say 16 out of 25 times 1,000. And what does that give me? Do it on your calculator, and that gives me 640. Okay. So this is just something in probability that we use when we are running experiments many, many times. We use the relative frequency to make predictions. And that relative frequency will start to become closer and closer to what we said the probability was supposed to be. So if we go back to the very beginning of dropping my toast, okay, there was, and you guys all said it in the chat, there was a 50-50 chance, 50-50 chance, 50% chance that it was going to land, that my toast was going to land jam side up, or what should we call it, the clean side up?
Non-jam
side up. Okay. Jam and non-jam. So that was a half and half chance. When I actually went ahead and did it, and I dropped the toast 25 times, it came out at slightly different. It came out at 16 out of 25, which was about 0.64. Not far off from the 50%, okay? So what we're saying is that if we're going to carry on and we drop the toast many times, it will get very close to what we said in the beginning, the 50%. Okay. So now you're going to try it with a coin, and that's why you need your coin right now. So any coin, any 1 Rand coin or a 50 Rand coin, not 50 Rand, 50-cent coin. And what I want you to do is just follow along on the screen. You're going to flip your coin 10 times. Now, Ms. Kaka, do you want to demonstrate the coin flip?
I'm failing miserably. I just realized that.
So you hold your coin like this and you just flick it, and then heads is the side. So tails is the side with the South African coat of arms on it, right? Okay. And then heads is the other side.
Okay. Okay, so
Guys, forget about the 25 times I dropped the toast. It was just a silly example. Don't worry about it. It's
so
just an
I'm gonna
example.
flip
Take
it,
your
hopefully I
coin.
catch it. Okay. Yay, I got it. I got it. Okay, so it's head side up.
Yeah. Okay, Watobians, so at home, what you need to do now is flip your coin. Forget about the bread now. Focus on your coin. And flip your coin and make a tally of the 10 times that you flip your coin. How many times do you get heads? How many times do you get tails? Okay, do that quickly, 2 minutes. Yes, guys, this is still a maths lesson. We can joke and have fun about dropping our toast, but now we need to get serious so that we can learn something. Okay, you've got 2 minutes, Watobians, to toss your coins and keep an accurate tally of each time you get heads and tails. Each time you get heads, make one little stripe in your table. When you get tails, you make a stripe, and then you total it up. Just 10 flips, okay? Just hold your results, please. Everybody, just hold it. Don't share your results yet. We'll share results in due course. Just listen to instructions, please, everybody. Don't put your results in the chat yet. Okay, just hold on your results. Right. Okay, everybody. Let's see your results. Okay, good. Excellent. So what you need to notice is what did we say? What is the probability of getting heads on a coin? What is the probability of getting heads and what is the probability of getting tails on a coin? 1/2, 50/50, 1/2. So the probability of getting heads is 1/2 and the probability of getting tails is 1/2. But when we actually do it, what happens? We don't quite get that. We get something that's a little bit different. So I get 4 out of 10 for heads and 6 out of 10 for tails. Okay, so 4 out of 10 gives me 2 out of 5. And I want you to work out Ms. Coco, just could you maybe deal with the comment that's in the chat? Thank you. So I want you to now write your probabilities like this as well. So how many out of 10, simplify it as a fraction, and then also write it as a decimal and as a percentage. So for whatever your outcomes were, whatever happened with your experiment, write now what that is. Yeah, do it for your outcomes, for what you did with your coin. Yes, Nazreen. Nazreen, you have a question? You can unmute.
Hi, ma'am.
Hi there.
I wanted to know if I want to find out the percentage, do I take the decimal and multiply 100 to get
Take your
the
decimal and times it
percentage?
by 100. Yeah. And Khomotso, you also
Okay,
have a
thank
question?
you.
You're welcome. Khomotso, you also have a question?
Khomotso is not connected to their mic, so it might be difficult for them to
Okay.
ask, but I'll talk to them in the chat.
Okay. All right. Okay, so what we needed to notice was that we said that the probability of getting heads is a half, or probability of getting tails is a half. When we actually tossed the coin 10 times, what happened? 4 out of 10 times I got heads, and 6 out of 10 times I got tails. And some of you also got something similar, but some of you actually got exactly the same thing. Okay, so what we got when we actually did it, that is called the relative frequency. Okay, right, now let's look at another example. You can put your coin away now. And let's look at this example. 100 people were asked to name their favorite meal. The results are shown in the table. Breakfast, lunch, dinner, and then each of the numbers. Okay, what do you think is going to go where snacks is, the frequency for snacks? Pop it in the chat if you know. 100 people were asked. Yeah, I agree. That's 11. So 11 people said their favorite meal was snacks. And how do we do that? Well, we know that the frequency must add up to 100. So we are missing 11. Now calculate the relative frequency that a person chosen at random says their favorite meal is breakfast. Okay, so their favorite meal is breakfast. We're going to just take the 17 and divide it by 100. And that is the relative frequency of the number of people who say that their favorite meal is breakfast. Okay, yes, that's right. Well done. Okay, let's see. Let's do another one. Okay, another coin flipping one. Okay, Josie wants to test if a coin is biased. What does it mean, bias? Bias means unfair. So it means that it can favor one side or the other. Am I a bit too fast? Okay, let's go back. Just ask a question if there's something you're not sure about. So we got the favorite meal. There's 100 people. Those are their favorite meals. We worked out what the 11 was, and then we had to calculate the relative frequency of someone who says breakfast is their favorite meal. So it's 17 over 100. We got 11, as Ms. Coco said in the chat. Follow along, guys. She said a little bit back, add all the others up and minus them from 100. That's how we get 11. There's 100 people in this experiment or in this example. So everything must add up to 100, and that's how we get 11. Yes, Lichlumile.
Sorry, ma'am, I didn't get the part. How did you get 11, ma'am?
Lichlumile, there's 100 people. All of these numbers in the frequency column must add up to 100. So 11 is missing. Okay.
Oh, yes, ma'am. Yes, ma'am. I understand.
Okay, let's go back to our next example. Josie wants to test if a coin is biased. She flips the coin 30 times. Here are her results. Okay, this is the last one we're going to have time for before our quiz. So let's make it a goodie. So there's her results. She flipped her coin 30 times. So complete the relative frequency table. So what you now need to do is count how many heads, count how many tails. And then fill it in the columns, heads and tails. Count carefully. Right, nice. There's a few of you got it quickly. And the quickest way to do it is to just count the tails and then subtract it from 30. So tails is 8 and heads is 22. Good, excellent. Now, let's think about this. It says, do you think the coin is biased? Explain your answer. So what does bias mean again? Bias means unfair. So if you look at it, you can see there's way more heads than tails. So is there something wrong with the coin that it keeps getting heads or tails? What do you guys think? Canva says yes. What do you think, Ms. Coco?
I think I'm not going to blame the coin. I'm going to blame the tosser of the coin. That's what I'm doing.
I agree with you because maybe it's the way the coin was tossed. Okay, so if we go back and we say the relative frequency, what we got here was 22 out of 30 heads and 8 out of 30 tails. And let's just simplify our fractions. 8 divided by 30 gives me 4 out of 15. And 22 out of 30 is going to give me 11 out of 15. Okay, so let's see who listened about relative frequency. So Josie decides, remember, we can use relative frequency to make a prediction. So in the experiment, this is what she got. 11 out of 15 for heads, 4 out of 15 for tails. So Josie decides to flip the coin 150 times. Calculate an estimate of the number of coins, number of times that the coin will land on tails. So we're going to take Ms. Coco, please could you just assist Anam? We're going to multiply by 150. Well done, Kabi. Yes, we're going to go 4 out of 15 times 150 because we are making a prediction. 4 out of 15 times 150. Okay, I don't get 110. I definitely get 40 times. Okay, so we use this number and we times it by the number of times, just like we did with my toast. And we get 40 times. Okay, that's all we have time for this evening. It is time for